Hello everyone. I'm going to be doing a video on how to balance chemical equations. The assumption is that you can already tell if a chemical equation is balanced or not, so we're going to work on actually balancing them out, proving that they do uphold the law of conservation of matter. Step one is to count all the atoms on each side, so let's go ahead and do that. I have potassium, and then I have oxygen, and then I have hydrogen. I have 2 potassiums, as you can see here by the subscript, 2. Oxygen, I have 1 here and 1 here. That's a total of 2. And hydrogens with a subscript of 2 have 2. Go ahead and erase those little marks. Now, I have to count on the other side, still on step 1 here. K equals 1, O equals 1, H equals 1. Now, if you have gotten to this point and you're not really sure how to do these counts, you definitely want to refer back to the previous video, which is about counting and determining if an equation is balanced or unbalanced. This equation is unbalanced. So we are now on step 2. We're going to determine where the deficiency is. That's where there is less on one side compared to the other. So we have one here, here, and here. We are missing potassium, oxygen, and hydrogen. Now that we've determined the deficiency, we're on step 3, add coefficients to the largest molecules that need it first. Never change subscripts. Very big deal. So coefficient would go out front. The only thing I can do is add a coefficient. I only have one molecule, so no choices here. It's already a 1, so I'm going to change it to a 2. And then I'm going to do recounts. 2K, 2O, 2H. Once I do recounts, I repeat until balanced, 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 and balanced. We are good. The new equation is K2O plus H2O reacts to form 2KOH. That is your balanced equation. We're going to go ahead and try one more. Let's go ahead and skip to the next slide. So we're going to follow the exact same process again. First, I'm going to draw a line down the middle to separate them. I'm going to start on step 1 here, counting all the atoms. We have a chlorine atom, and we have 2 of them actually, because this is a chlorine molecule. So 2 chlorine atoms. Then we have a iron atom, Fe, and we have 1 of those. And then we have chlorine atom on this side. You want to keep them across from each other there. And we have 3 of those with that subscript. And then we have iron, and we just have a subscript of 1 there, so that's 1. Now once again, if the counting confused you, you're going to need to refer back to the previous video or come in for assistance. This video is about balancing. So now that I have these counts, I want to determine where my deficiency is. I see that the chlorine, there's 2 on this side, and there is 3 on this side. So I think I'm deficient over here. I don't have enough chlorine on this side over here. The iron is okay for now. So now that I've determined my deficiency, I'm going to move on to step 3. Add coefficients to the largest molecule that need it first. Well, I don't really have a choice. What I have to do is I have to get more chlorine atoms here. So I can only add them to this one spot, this Cl2. So because I can only add coefficients, I'm going to change this from a 1, which is what it is when there's nothing, to a 2. And then I'm going to recount. 2 times 2 subscript is going to give me 4 total chlorines. So then I'm going to go ahead and erase my deficiency arrow, and I'm going to look for deficiencies now. And as you can see, I have created one over here. Now it's deficient on the other side. And so I'm going to have to add, and I'm in the repeat process, repeat until balanced. I go back to adding coefficients here at step 3, and I'm going to make this a 2 because I can't add anything else. I can't put a subscript in here. I definitely cannot change this to a 4. No, 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 because that's the subscript part down here. So we can't do that. So I'm going to put this 2 coefficient, and I'm going to recount this to Fe. So that changes that. Be careful. A lot of times students forget that to count everything in that molecule, they oftentimes just recount the one atom they were trying to change, which in this case is chlorine. So how many chlorines did we change it by? 2 times 3 is 6. So we went from 3 to 6. So at this point, things really look like they're getting worse, and that's okay. We're in the recount, repeat part again. So recount, look for deficiencies, and let's see if we can't fix this thing up. So now we're missing an iron over here and a chlorine over here as well. So definitely on the left side at this point. So I am definitely going to add more coefficients. I have to add more of the iron, but I want to add to the largest ones first. So I'm going to go ahead and make this chlorine a 3 instead of a 2. And then I'm going to do that recount like it says, step 4, and that's going to give me 6 chlorines. And then I'm going to not have a deficiency there anymore. Leaves me with one deficiency here. My deficiency here is by 1, which means I can just change this to a 2 subscript, recount the iron to 2. So I have 6 and 6. That looks good. And I have 2 and 2, and that looks good. And as you can see, we have a balanced chemical equation with a chemical formula of 3Cl2 plus 2Fe reacts to form 2FeCl3. That is our finished product, and that's how you balance a chemical equation. If you have any other questions, please rewatch the video, and if you continue to struggle, please come in for assistance.